This is another episode of Geezers and Gurus on H.V.A.C. My name is Carl Darge, and I have a special guest today, a friend of mine, Jim Partridge. Jim and I work together to find out why people get carbon monoxide poisonings or why buildings have issues. But today, I have borrowed his genius and his knowledge on how to lower your carbon footprint. Now, this is the whole purpose of this podcast and all this stuff. But we have to start somewhere. So on this whole process, we start with the envelope of the building. Now, we can get into a lot of different ones, pole barns and all kinds of things in commercial buildings. But most of the buildings in this country belong to families that have to deal with the energy costs. So, and we want to try and make it a little bit clearer so that you can, how shall I say, assess your own house. So we're going to go through it. This may not pertain to every house built in America, but we're going to go through it. We're going to try. We're going to start what we say at the bottom up. So if you have a basement, this is where we're going to be talking first. I know there's a lot of people in this country that don't have basements, but there's an awful lot of people that do. So as we start this process, we're going to talk about the whole shell of the structure and what we can do to improve it and what we should be looking for. And so with that, I'm going to turn it over to Jim for a minute or so that he can introduce himself and sort of give us an idea of his credentials. Jim?
Got me. Okay. Simple. I'm, like Carl said, Jim Partridge. I've been a licensed mechanical engineer in Michigan for more than 40 years. Lately I've got heavy into the forensics when the economy shifted quite a bit, but that still was all part of it early on in the game when you're dealing with large projects and small projects. So I've got 40 plus years actually if you get technical, doing buildings, all kinds of buildings. So this whole business of the envelope really is every building that we've ever built. And so what is the advantage of being proactive on your residence, or even if you're a new residence as well? So there's where we'll begin. The key issue, let's talk in terms of existing buildings.
I think
that's the good ways to go, because most of the people
right.
that are going to watch this are going to do the same thing.
And in existing basements.
And existing basements or existing crawl spaces.
Right, both of them.
Yeah, and so if you really get right down to it, which is the one that's going to give you the biggest bang for the bucks? Believe it or not, it's going to be the crawl space.
Exactly.
But big time. So
that is a forgotten spot in the house because it's out of sight, out of mind.
Yeah.
Basements, people are there, they're in there. If they're cold or have drafts, they can do that. But a crawl space, I don't know of anybody that's thrown a party in a crawl space. Okay, that's not something that happens. And they're trying to get the husband or somebody to go down underneath there is also problematic. Another thing that, like in the state of Michigan here, they don't allow us to install furnaces and things anymore in crawl spaces unless they're basically set up like a basement with concrete floors, lighting, and all that other stuff. So crawl spaces, nasty. Crawl spaces have ground. Crawl spaces have outside walls. What else?
yeah, they got the sill plate
Sill plate.
and ledger.
Mm-hmm.
So those are two big ones, and those two in combination basically is it.
Okay, now we're going to explain how the sill plate and your outside walls at the top of your block wall, whether you have a basement or not, and how this works. And this is our little drawing here behind us. So, Jim, why don't you go through and explain this one? He drew this one.
Okay, outside, inside, masonry block wall, and you're going to have ledger here, and you're going to have a sill plate across here, and you'll notice that we have three little arrows where it's here in the other diagram, which basically indicates that this is air infiltration. And we're ignoring the fact that it's that right now because we're going to insulate this to keep that cold from coming into the attic and coming straight through and falling to the floor. So the bottom line is everything you see in blue is wood. At this point, there's wood across here, that's the floor. Here's the 2x4 up on the floor, and then here's whatever the
Wall
exterior
stack.
wall is.
Yeah.
So what we've got is, and you can see here, there's some wigglies. Basically, you take some rigid foam, cut it about a 1/4 inch smaller than the distance between the floor joist and the rest of the space.
When
Then-
we are saying foam, are we talking the white foamy stuff?
No,
or
you go green stuff, anything to
Green,
stop the draft,
yeah.
anything,
Anything.
keep it simple, yep. And
Okay.
as long as you have you can make it a 1/2 inch if you want to, and just foam around here. And I put a second one in, so now you get a bigger R value across here. Doesn't have to happen that way, because this is out of scale. Usually this is gonna be significantly, probably 10 inches or so, depending on the house and how old it is. But the bottom line is, you've got foam here, and you can do a little bit over here, this edge, which takes care of this corner. And if you really want to get serious, and you're looking at everything and it's shrunk based on its age, bottom line, this is a easy Saturday project.
Yep.
Go to your box store, get yourself a couple of 2-inch foam. XPF would be preferred, get the biggest R value you can. Then you can make a bunch of cuts. Just cut them all off, couple of bottles of foam, and away you go.
When you cut these things, you're gonna have a piece of foam, whatever size you're gonna get. Let's say it's a 2x4, whatever.
That's it.
So when you measure in between here, you're gonna have a 2x10, 2x8, 2x12. That's about it. If you get anything bigger than that, you ain't doing it. You got somebody else to do it for you. So this space here this measurement will always stay the same. The measurement that changes is the measurement between the joists. And that won't change a lot. So if you make it all the same, if you run it lengthwise, you have these long pieces. When somebody's standing on the ground, you get a long piece, that's just the height of your joist, that's what you want. Somebody will say 13, snap, 12, snap, 14, snap. Easy to do it. You got a long piece you're working with. When you get down to the end, you can put the little piece in there and just put another one on next to it. You will never run out, but make it easy for yourself. And that's my suggestion here. Okay, Jim?
That basically, when you're all done, you'll see tremendous. Now, if you're in a crawl space.
You were telling me earlier, Jim, about what the utility companies say. What is the heat loss on this area of your house?
That's 10%. That's what the local utility has been promoting for a long period of time. And I have no doubt that that's probably conservative.
Exactly.
Yeah.
I will also say this, if you are involved in any of my movies, in my movies I actually show the sill plate, and we happen to have it just at the right thing that you can this is in a new construction house, that we got it and we caught the sunlight coming between the plate
the two.
and the outside. And that was explained to me. Let's say what you want to do, you want to know how bad it is, go all the way around and measure the perimeter of your house. Let's say your house is 25 feet this way and 100 feet this way. So you've got 250 feet of perimeter on your house. If you have a 1/16 of an inch gap in there, if you convert that 1/16 of an inch to square inches, which is easy enough to do, if I had my calculator do that, but you're looking at a hole in the side of your house like this. A hole in the side of your house like this with the wind blowing. Do you think that you're going to be able to stop that and all that heat? Now, how much you're losing? That's true. That's how much you're losing. So when you caulk all of that, you just put a very big hole out of business. Correct?
No problem. Now, if you really want to make some significant improvement in the crawl space, which is where we are,
Yes.
is there's going to be amount of dirt between here and somewhere down in here. We don't know, they're all gonna be different. The point I'm making is, do one other thing, is here, insulation. And that put it down below
The ground level?
the ground level. Now, when you've done that, now this little bit of foam now goes right in here. So now you've really stopped it. Now, once that's done, now you can say, okay, that's well and good. Well, it really isn't, because we haven't talked about plastic on the floor.
Mm-hmm.
It's dirt. It radiates lots of moisture. And if push comes to shove, the ideal scenario is, let me change this a minute. Maybe a green will work. You can take this piece up here and do that.
Plastic.
That's plastic. Now, once you're up here, again, right like that, that's down there, doesn't have to be fancy, and just put it below grade. Now, what you've done is you've isolated that, but we're gonna tell you here is continue with your plastic across the floor, but it needs to have a good 6 inches of overlap.
Overlap.
So now you got the 6 inches in here, and nice, doesn't have to be tight, doesn't have to be fancy, but you need to close this joint right here. Tape.
Okay, now, if you remember my other videos and other things that I've talked about, your taping friend is your packing tape dispenser that you can get at any place. All the tape that you might want to use, which if I was me, and that's plastic down in there, sounds to me like Costco, a taper, and with 6 rolls of tape is more than enough to do the whole project. More than enough.
Very easy.
And you spent less than $20.
Now, the code starts to get in the way, because they don't care about this. But if you're gonna do that,
What code is? Are we talking energy
Residential.
code or building
just
code?
call it just the energy code.
Energy code.
Just energy code. But the thing is, you're now trying to do cost avoidance. So, but how do you control what it's like below the floor? And the easiest part, and you can buy, and got to remember one thing, we skipped over it. If there's a crawl space, there's a ventilation louver right here in the sidewall. Cut a hole in it, and that's been there. It's got a cover on it, well, a grill, and that's it. Well, we've got rid of it. So
Yeah.
now it's completely gone. We've eliminated the vapor coming out of here, but what we also need to do is we need to exhaust this space right here. Throw it out. And what you end up doing, you buy yourself a fan that you can buy, and there sits right here. You can nail it right at that location, and this will move about 50 CFM. That's all you need.
In the whole crawl space.
And the whole crawl space. And if push comes to shove, that runs 24/7. But what it does, it pulls warm air from the floor above.
So we're talking 50
CFM,
CFM.
cubic feet per minute.
That's
Yeah.
not a lot.
No, but
folks.
the whole thing
That
is
would be
small.
a teeny tiny itty bitty bathroom. Ventilator.
No, you don't want to use
Well, I mean,
that. They have.
Right, they have the
They
correct
have
fans. for it.
correct fan.
But it's not a lot of ventilation.
No.
It's enough to keep moisture content and air moving through there so that you don't have funny
And you
things.
don't have to cut a hole in the wall, it's already there.
Yes, if you have a vent, it's
If
from
you
a
vent
little
on
crawl
it,
space.
you put
Right.
that in, and you only need one. If you feel like it's big, maybe you've got other issues we don't know about, then you put 2 in. It's not that difficult. The only thing, and a lot of people will not know this, but GFCI, ground fault interrupting receptacle, has to service this.
Ah,
So you bring a
GFI.
little,
Yep.
yeah, you just bring a little piece of number 14 wire in,
Yep.
put it in a J box, put a receptor, a GFCI, plug it in, you're good to go.
Protected.
Don't have to do a thing.
One other thing before we get away from this one, is to go a little bit higher. The plastic here that you're using, 6 mil should be the thinnest that you get. You can obviously get heavier than that, but 6 mil, if you're not going to be down in the crawl space and your kids are not going to be playing down there, 6 mil is good. You got to make sure you get it into place because it moves easily. It's not that heavy. So a minimum of 6 mils.
Yep. And it's a good place to store your wine.
Oh, yeah.
It is.
Good. So,
Okay.
all right, so now which one, where are we going from here? We got the crawl space.
Not crawl space.
We want to move up to,
Well, let's look
let's
at.
just talk to, let's do one that just, we're talking the wall, now outside wall. We're gonna have a lot of people here that are gonna be living in houses built before 1990. Probably most of the people out there. And the houses before 1990 were not insulated or done anywhere near what they're doing now. With the sheeting on the outside, with the Tyvek. I don't know when Tyvek came in now.
It's been a long time.
Been in there a while.
Oh.
I have to look that one up. But, yeah. So should we do that as the next step, is taking the wall up to higher?
No, because now you're into, well, if you're doing new construction, and I'm looking at this isn't new construction,
No.
so you're not gonna
So
have.
you don't have to
have
worry
it.
about it? Okay.
No.
All right, now we're out of the crawl space and out of the basement area. Crawl space is a really nasty spot. Basements can be really nice if they're done right. But now we're into the main living area on an existing home that you went and bought. We're looking at the outside walls, and as Jim just pointed out, there isn't a lot you can do with an existing house on the outside wall. It is very expensive if you have no insulation in those walls to get new insulation put in. It's not saying that it's not worth it, but I sure would have a price ahead of time to figure out how long it would take you if you saved 30% of your bill, I think it would
What,
be.
by doing what?
Insulating the outside walls of a non-insulated house.
Oh, for a non-insulated house?
Yeah.
Oh,
Or
I don't know that you go a long time way back when you got 1.5 inches. So you're really talking
early 50s.
early 50s. So how many people have done that? Again, there are people out there gonna have that. So
If you have 3.5-inch insulation, which is like most of the homes from 1960 forward, that's pretty good. You can't really make it any better.
nothing, you're stuck.
And if so the other part, what's on that outside wall? What can we talk about? Well, windows. I grew up and I worked in custom homes my whole life, and I remember Four Seasons aluminum windows was the finest window you could put in. If you had a Four Season aluminum window in your house, you had a really good window. They're out of business, and I pass their building all the time. Like all aluminum window companies, 99% of them went out of business. So in today's world, we have plastic, vinyl, which is the same thing, wood, and fiberglass. All of those are good. The transmission rate through these windows is nominal, right? I would say. Currently.
Well, depending on how it's installed.
Right.
That's just the perimeter.
It is the perimeter. So if for replacement windows, you have to be very careful of who you get to install them. I've seen a lot of bad jobs where they just sort of take the old one out, put the new one in there, screw it in place, and they're pretty much out of there. And there's a big gap that they cover up with the window that they don't address and insulate. So it depends on the customer. It depends on the company you get. That's a hard one.
It's not easy because everybody's going to look at the ones that are replacement windows.
Yes.
The replacement windows are wonderful, except they are not energy efficient. Period. Now that's, I get a lot of grief from the people that sell it, but we need to protect the perimeter from air infiltration. And if all you're going to do is take the old window out and put a new window in and do nothing else, you're never going to get the money back in 30 years, not even 40 years. So you really need to be cautious if you're gonna replace a window, what you're gonna replace, and
How it's installed.
Installation is very, very important. And there's a lot of people out there that are not installing in accordance with the manufacturer's published literature. And that's in the code issue, because it says, if that exists, you gotta follow it.
Okay, so you are, an average person, and you just listen to what this person said, and you say, well, we need new windows, what am I going to do? Let's say he just said, manufacturers published literature on how to install these windows. You have a contractor comes up and he says, I'm using Adam's window over here. Okay, go online, go to Adam's window, see what they have for their installation instructions, and take a real close look at it. And then you can question the installer on what brand name of foam insulation do you use when you put the windows in, stuff like that. In other words, you're fishing. You're fishing to find out what this guy is actually going to do. You want him to tell you what he's going to do, and then after you have already read the installation instructions from the manufacturer, you can tell if you got somebody that maybe he's just throwing this thing in there, or he's doing a good job. If you want to get your money out of there, it's not how much money you're spending at this point. If you got two contractors, and let's say they're doing a whole house, and it's $6,000 difference in price, you want to look at it. But you can, if you get the wrong guy in there, that $6,000 is going to seem like a dinner out one night. Because for the rest of your life, your energy bills are going to be through the ceiling, whether it's summer or winter. So that's really important. Also, penetrations to the outside. You got the walls of your house. What do we penetrate the outside with? Well, we got windows. We just talked about that. And we have ventilation. Ventilation is very big in our homes today. We have kitchen hood fans,
Yep.
Bathroom fans, clothes dryers. What else?
Those are the paramount ones.
Those are paramount, okay. And all of that adds up to quite a bit. And the penetrations through the walls, we're talking about air infiltration here again. Where's the backdraft dampers? Is the piping? Let's talk about piping and other things for fans. Let's do ventilation. So go ahead.
Okay. The key issue is backdraft dampers on bath fans, dryer. That's probably the one that's going to be the worst one, because nobody looks at the dryer exhaust.
Well, it gets all plugged up quickly.
And especially if it's in the basement and somebody gets lazy and just decides that, oh, I'm going to punch it through the basement ledger, and you've got a lawnmower who doesn't have a catcher. And so you go blasting by it, and what do? You end up having that discharge covered with grass.
Mm-hmm.
And so we wonder why the dryer isn't working as well as it should. It's time to check the outside and see whether or not you have an issue with regards to debris from the lawnmower. That's the one that we've encountered more than once. It's there. Kitchen hood is another one, depending on how you feed and how much you're grilling and all the rest of it. Keep an eye on it, because if it doesn't close, all the fans, if they don't close, they're exfiltrating. So now you've got warm air going outside. Now you can say, yeah, but what happens if my predominant wind direction is where it is, and if it's southwest and you're facing southwest and you got the wind blowing, it's going to be reduced. Let's not kid ourselves. But at the same time, it needs some minimal maintenance.
Mm-hmm.
Very minimal. Don't have to do much. But especially with the dryer.
Keep your grease filters checked in your kitchen stove too. That's the only place that you have them like that.
That's it.
And for those people who have the old style fireplaces and gas logs, make sure that damper is shut in the summertime, and make sure that it's not shut at all in wintertime, especially if you have a pilot on your gas logs. That I would say. Another thing too is, boy, we're doing good here. We're just telling you all about all of these little improvements and how we're sealing things up. Your doors are another big one, and I'm going to say this because I just came back from trips to Texas and Florida. So I'm not saying anything against people in Texas and Florida, but both of them had air conditioning things going on. My daughter-in-law in Florida, in Texas, they were about to spend $7,000 on a new air conditioning system because they were having issues in their house because it wasn't cooling. It took me less than 15 minutes to fix and find the problem. And I'm going to tell you what I did. Number one, I went out and washed a condenser really good, gently with a hose, no chemicals. Number two, I looked where their air handler was located. It is located in a little walkway between the family room and the garage. You walk in there, there's a place to hang your coat on one side, and on the other side is the air handler. There's a big grill down there for return air and another one in the family room. So that's telling me right off the bat that whoever put it in there wasn't a really good HVAC contractor by using just one central return at one end of the house. That has a tendency not to work, especially when you have air conditioning only situation and the return air is on the floor. If stupid was a drug, the guy was drunk. So, because it's the first, we all know that cold air falls down, so it would be stupid to pull it back up and run it back through the air conditioner again. Okay, the other problem, now you say, what was the problem? Why did they have an issue? They closed the door between the family room and that little closet area. When they did that, half the return air was in that space. So that little air conditioner is running its little brains out. In about 30 seconds, it drew enough air in from the garage to make the air pulling back into the air conditioner about 100 degrees. They were actually pulling air from the outside around the garage door from a closed garage because how much is the weather stripping for a door?
Oh, nothing. It's inexpensive. So easy to do.
Give me a break. That was the whole issue. Somebody's going to sell them a $7,000 air conditioner because your garage door wasn't weather stripped. So that's Texas. See the same thing in California. I've seen the same thing in Florida. These southern states, you people think that just because you're in a warm climate that the heating rules and regulations don't work on you. All you have to do is look at your house in reverse. Instead of trying to heat your house, you're trying to cool it. Instead of trying to keep the cold air out, you're trying to keep the hot air out. It's just the reverse. The rules and the principle of insulation and airflow and all of that stay the same. There's no difference. So in other words, half the country is not insulating their house correctly, their equipment is not installed correctly, and their weather stripping, to look for a better word, really sucks. So with that, if you got something else, where are we going with it? Does that sound good?
No problem with that.
Well, there we go. So here you are as a homeowner, and you're taking a look. Also remember this. Which way does the sun shine? You can get in your home, nice box stores. If you are living in Florida or Texas or anything, and if your house is improperly built, which means it doesn't have any overhangs on the inside of the house to shade your house from the sun, you should really look into putting in reflective film. I know it does not work on low E glass, so if you got low E glass, you've gone as far as you can go. But on all the other ones, you can put this film on there. It will stop 70 or 80% of the reflective heat. It reflects that much out. I have used it on commercial buildings myself, and it really, really works. Another thing you can do, if you can't do it, is curtains, of course, so that you need, and blinds. I know that blinds, you can get blinds that have one side is silver, so you can turn that to the bright sun and block some of the heat out. So there are ways with your window treatments to be able to help sustain in the air conditioning, and it works the same way with heating. We have heavy curtains that you can close at night to prevent the heat loss. Because the first rule of H.V.A.C. and physics and God and everything is hot goes to cold every time. High goes to low every time. That's the first rule. So if you're sitting in Texas, the heat on the outside is trying to come in. If you're sitting in Minnesota, the heat on the inside is trying to go out. And what you have to do is put the barriers up to stop it, no matter which way the heat travels. You cannot stop heat from traveling through something. You can only slow it down. That's what the R is for. Resistance. It's not 100%, it's just a percentage of resistance to loss.
A couple of things that I've made notes here that you can see on the computer. Building America Solution Center Resources. Solution Center, one word. Building America Solution Center Resources. Lots of good things, won't be applicable to everybody, but pick out what you need. Then the other one would be Efficient Windows Collaborative. If you're thinking about Windows, that's the place to go. And you get educated, and if not, and you can replay
Yeah,
this
there you go.
scenario, and it'll be fine.
Right, you know, I have a book here. It's called Manual J.
Mm-hmm.
It is for going through and figuring out heat loss and gain on a house. When you come to the Windows section, which blew me away because I have always looked at that. Let's talk about insulation, period, in any form. Insulation is what it is because of the captured air within it. If I had an R38 fiberglass insulation bat, and it'd be about that thick, and that's R38. If I take that bat and push it all the way down to here, it's no longer R38. You'd be lucky if it's R4 or 5. What have I done? I have taken the air out of it. Okay, that is true for windows too. So you have an air space that's in between the glass. You have a single pane glass, which the idiots in Florida and Texas like to use. And then you have thermal panes that normal people in the north here use. And that dead air space is actually the insulation on the glass. So if you got 1 inch of airspace, it's obviously a lot bigger than a 1/4 inch or 1/2 inch. But this is what I found out when I read the Manual J. Let's go back to the 1800s, where they had windows with single pane glass. And then they had a 2.5 inch airspace, and they had these things called storm windows that went on the outside. Complete piece of glass went right over it, they sealed them in. In the summertime, you had to take them off, and then you hooked the screens in, and that was a big deal. So we came up with new styles for that. That 1800 window with the single pane glass, the 2.5 inch airspace, and the single pane storm window that was pretty well sealed, is the most efficient window you can put in the house. And with that, I'm going to leave it.
Sounds good to me.